Alright guys, quick recording for you all. So, Leetcode problem number 88, merge sorted array. Essentially you're given two arrays. Each array is already sorted. So here's the first array, nums1. Here's the second array, nums2. And then what you need to do is merge both arrays into one array that looks like this and is sorted. And you would store the result in nums1. So nums1 you would modify in place, right? So the code for this looks something like this. Essentially you make a pointer to the last index of the nums1 array. So we'll call that pointer I. It'll be right here at the number 3. We don't count these zeros because these are just placeholders. Leetcode makes this easy for us by not requiring us to allocate memory dynamically. So instead they have already pre-allocated this memory for us, so we just need to replace the zeros with the proper values. Alright, moving on, we have another pointer j that's going to be pointing to the last index of nums2, so that's the 6 here that I'm highlighting. And finally we'll have another pointer k, and that will be pointing to the last index of the final array. So remember the final array is nums1, so k is going to be pointing to this very final 0 right here. And the idea is that we want to make sure that with each pass within this loop we have the biggest element from both arrays is sorted into the final array. So that's the goal. So with each pass we'll make sure that the last element is sorted, and then the next pass we'll make sure the element before the last is sorted, and then the third from the last, and so on and so forth. So here's the loop. We loop down from the end of the second array down to 0, down to the past the 0 index. This is just an array boundary check. Make sure that I is still valid. We care that I is still valid because we're decrementing it right here. And then what we're saying here is if the pointer, if the pointer that I is pointing to, the value that I is pointing to is bigger than what is in J, then we actually want to move that I towards the end. And then vice versa, where J is bigger, move it towards the end. Let's go through a PowerPoint slide and let's just see how this works, okay? And just to show you, this actually works. So let me click submit, and you see that the code runs beautifully. So it looks great. Okay, let's go through the PowerPoint slide that I've got right here. Okay, so here's the start, right? We got nums1, nums2, my I, my k, and my j. Showing where they're initialized to. After the first iteration of the while loop, what ends up happening is that we update the last element with the value 6. The value 6 comes from nums2, so the last value of nums2. We choose 6 because we're comparing 3 and 6. 6 is greater than 3, right? So we move it to the end. And then we decrement k, so we move k down to the next element to sort. And then we move j down as well. Let's continue the example. Here we are, we've made our next pass, and we are comparing 5 and 3 and then once we compare 5 and 3, 5 gets put into nums1, and k and j both get decremented accordingly. And then finally the third pass is we want to compare 3 and 2. So 3 is actually bigger than 2. So in this case, we actually keep the j pointer the same, but we move the I pointer back 1. So now let's compare I with j, so both of them are 2, right? So in that case, we'll just put 2 right here for k, and then we'll call it done right there because j is now out of bounds, right? And so that kind of lines up with the code that I've shown you here. Just kind of requires a little bit of sitting down and thinking about it, walking it through step by step to really understand how this actually works. Thank you for your time. Hope you found this useful. Let me know if you'd like to see anything else. Peace.